Hi, I'm Steve Krims. Welcome to Back to Basics. Today we're going to discuss IoT, specifically how to secure communications, ingest data, and take actions on that data based on your desired business outcomes. I've designed architectures in the past where securing individual data streams was not a high priority. That would not be considered best practice in today's internet-connected world. I'm going to show you how to build policies that scale and are secure. You're going to see how identity and authorization are the foundation for designing your architecture while keeping your device telemetry data and command and control messaging restricted to only devices, services, applications, or identities that you have authorized. We will look at how you could scale this to support a large number of devices, customers, and work streams. MQTT is a publish-subscribe, lightweight network protocol. MQTT, a topic structure, represents a hierarchy of information separated by the /. You need to consider what should be publishing to those topics and what should be subscribing to those topics. How do you create an authorization policy to allow for meaningful topic design while adhering to best practices and the principles of least privilege? Let's start by looking at a device. Each device should have a unique name that will be used as the MQTT client ID. Each device should have a unique identity attached, such as the X509 certificate that is registered in IoT Core registry. And finally, you need to attach an IoT policy that has been appropriately scoped down to grant access to only what is required to perform the desired functions. To say this another way, the credentials authenticate the identity. The IoT policy document then authorizes what that identity can access. By defining the thing name variable as part of the IoT Connect resource in the policy document, only the device presenting the client ID and credentials matching those registered in IoT Core will be able to connect as that client ID. When creating policy documents, you should also be thinking about the MQTT topic design and hierarchy. If a device is sending temperature, CO2, and humidity levels for a particular greenhouse, it might publish to data, air sample, greenhouse 3. Part of this policy document that would allow this action is displayed here. Let's consider an application that subscribes to this topic so it can display this information on a dashboard. The IoT policy for the application would include authorization to subscribe to that same topic. If you deploy these sensors to multiple farms of multiple greenhouses, how would you design the IoT policy to do this? How about multiple customers? You would not want to create a unique policy for each device, and we should not create an overly permissive policy allowing publishing or subscribing to any topic. Here we show multiple devices publishing telemetry data to the same endpoint, but on separate topics. We need to ensure that customer 1 can only publish and subscribe to topics authorized by customer 1, and the same for all other customers. You'll notice there is a wildcard at the end of the resource. This allows you to publish on the secured topic with a scoped and secure topic structure, but flexibility to publish on separate subtopics as needed. You may want to publish air sample data to air sample, soil acidity to soil pH, and so on, each to a separate subtopic. The IoT policy shown would allow this. By utilizing IoT policy variables, we can use the same policy for devices that will be performing similar functions. By replacing the customer ID, farm ID, and greenhouse ID with policy variables, we can use the same IoT policy for all of these devices while still appropriately restricted to the topics as designed. The policy variables are attributes that are stored in the IoT Core registry. By creating separate top-level topic identifiers, you can separate command and control messaging from telemetry and ingest path. You could create the IoT policies the same way for custom and mobile applications, but again, using policy variables to restrict the identities to the own devices by customer ID, farm ID, or device ID. Shown here is an example of authenticated users from customer 40 that are authorized to publish to a topic that their device is subscribed to, but restricted to only customer 40. What actions do you want to take on the data being published by your devices? AWS IoT rules allow your devices to interact with AWS services. Rules are analyzed based on the MQTT topic, and one or more actions can be configured to run. We talked about lower-level subtopic identifiers previously, so you can create separate work streams or actions based on these subtopics. UV data is published to a separate UV subtopic. Data published here could trigger a couple of actions. Publish the metrics to AWS TimeStream and run a Lambda function to determine if shutters should be activated to increase or decrease light in the greenhouses. These actions would only trigger a rule match when data is published to the UV subtopic. Telemetry data being published on the soil acidity topic may have a completely different workflow, so the rule will only match when data is published to that topic. This will help to optimize costs by only evaluating rules when relevant data is published. It is important to note that multiple rules can subscribe to the same topics. In this example, the device is publishing air quality, soil, and UV information. One rule has a wildcard and will match on all data written to these topics. This data is being passed by the rule to AWS IoT Analytics. The same message is matching the rule that is subscribed to the soil pH subtopic and will trigger the actions defined by that rule. One anti-pattern to avoid is creating a rule that matches many topics but may not contain relevant data. This will cause a rule match with no action taken. Today, we explored IoT Core variables and how to use them to build secure policies at scale. Please check the links below for more details and resources. Thank you for joining me today on Back to Basics. See you next time.